Hello everyone, welcome back to this amazing session of Big Data Analytics. And last class we had completed the chapter 4.1 in which we covered everything about like introduction to NoSQL. Okay, so now let us continue with Hadoop. Okay, so here in this video we will be giving an introduction to Hadoop because in second module we have completely in detail, in depth everything about Hadoop. But here we'll just go very short introduction because it's in module 1. And remember, if this question has come in module 1, then you don't have to worry because you will be studying this in depth in module 2, so it will be a piece of cake for you to answer if this question arrives in module 1. So what is Hadoop? Hadoop is nothing but it is a distributed system which has multiple nodes. Basically, it takes data as input, analyzes and gives us a valuable output. Okay, so features of Hadoop. So see, there are many features of Hadoop. Here we will be talking everything one by one. It's just introduction, right? Features of Hadoop handles huge and varied data in the sense what large number of data and varied data. What means what? Structured, semi-structured, unstructured. Shared nothing architecture in the sense what it has its own memory, it has its own CPU, own processor, so it's independent of other things. That's why you don't have to worry about if anyone fails, so it will still keep on working. Replication, it allows replicating the data into and distributing into different nodes, so that if one node fails, the data can be retrieved from the other. So replication is very helpful. High throughput and not low latency. High throughput because it has batch processing. So with this batch processing gives us very much good throughput, but we do not process real-time data. It is just batch processing in the sense offline data or already stored previous data. Not low latency in the sense, see, latency is something in the sense how much time it took. If you say low latency, very less time, high latency, very high time. But here we have not low latency, which means it does not have very small waiting time, but it might be medium or high like that. Complements RDBMS in the sense what it does not replace RDBMS, it just complements it, which means what it also takes makes use of RDBMS like OLTP and all. Not suitable for small size data and all or parallelized data. Okay, so key advantages of Hadoop: stores data in native format, so you don't have to define a schema for storing the data. So data can be stored as it is, as it comes. So whenever schema is required, you can imply it, but you don't have to predefine a schema over here. Scalable, so it in the sense you can process large amount of data. So petabytes of data can be shared among different nodes, multiple nodes. Cost effective, these nodes are very cheap. Resilient in the sense what since it replicates the data, so you do not have to worry about data loss or any tolerance. So it has good fault tolerance and data recovery. Flexible and fast. Flexible means works on very multiple types of data, semi-structured, unstructured, and what is that? Structured. Fast processing, does not take much time for processing all this data. Hadoop versions. Okay, so we have versions of Hadoop. We have Hadoop 1.1 and 2.0. 2.0 is nothing but one single addition to the Hadoop 1.0. 1.0 consists of HDFS and MapReduce. What is HDFS? Hadoop Distributed File System. So it is a file system, so it does not operate with SQL. SQL is nothing but what you call as SQL. Okay, so a technical term for it is SQL. So it does not use this. So we cannot. So it is not real-time processing over here. HDFS. So it nothing but it's a distributed system. Multiple nodes are interconnected, and large amount of data is shared among these nodes. MapReduce. It is a function which has two parts. One is mapping and one is reducing. Mapping is nothing but always remember, mapping is always like match the following type. So it takes the input, converts it into key value pairs, and then gives to this moves to the reduce pair where the data is nothing but compressed or aggregated, rearranged, and duplicate data are being removed over here. In Hadoop, and MapReduce function requires Java expertise and all. And if you are tightly coupled MapReduce functions are being used, then the flexibility reduces. So that is one slight problem over here. For that we have introduced Yarn over here, yet another resource negotiator. So it handles a cluster of resource management. With this addition, now you don't have to rely on MapReduce. It is just an option now. MapReduce is just an option. So it allows for you to batch processing along with real-time processing. And then what it does, so it makes it easy for us not to rely on Java and all. So it has pig and hive, so it is nothing but SQL features which will be available just because of this addition of yarn. Overview of Hadoop. So there are four overviews in which you have to talk about everything is related to data. You can see here data. So you just have to talk about data over here. Data ingestion is nothing but taking in the data, taking data and collecting the data, taking it as input. So in that you have scoop and fume. What is scoop? Scoop is nothing but SQL plus Hadoop. So it is just a fusion of this. I didn't know how many fusion does, but yeah. So you just merge this. So they made it as SQ. They removed the L and they removed the HAD. So they made a scoop. Okay, it's similar storing the data. So mainly what scoop does, importing, exporting the data between RDBMS and HDFS. Okay, remember, importing, exporting data between RDBMS and HDFS. Scoop does that. Flume is a log aggregator in which it collects all the log data from the web application and gives it to the HDFS. So see, it's all like taking in data ingestion, data storage, HDFS and HBase. See, HDFS is a distributed file system which stores large volume of data, but HBase is nothing but a database, and it has no SQL column oriented. It is no SQL and no SQL. That is no SQL column oriented, in which that means we can have multiple columns. So one row can have thousands of column per row, and it supports real time processing. Here only batch processing. So data storage different type. You have to see the difference between this. You can see that in my notes. Data processing, that is MapReduce and Spark. MapReduce we already discussed the same thing. Spark, it is nothing but high performance computing platform, which allows you to related to log and all. So same thing. It also allows you to process the data. So from the word you can understand it's high performance in memory computing platform. Okay, so data analysis, pig and hive. So pig and hive are a part of HDFS. Sorry, not HDFS. That is different. Hive is different. So you'll be so there are pig, hive, and impala. Okay, so pig is something it's like a language type of thing in which you will be using a script. So the script is just similar to SQL. How in SQL you use create table, insert this, for this and all. Same you write in Pig Latin language. So the script we use is Pig Latin, in which you write the code and it then converts into MapReduce. Same goes with Hive. In Hive uses the language called HiveQL. Okay, so Pig Latin, then HiveQL. You can see here, right? So these two are used. Script languages for Pig Latin, for HiveQL, and then the main thing both of them does is converting to MapReduce functions. Then Impala is nothing but it is also a very high performance SQL engine. Okay, very high performance. So it gives you very low latency, very fast. It was very fast. So you just have to know that much about that. Hadoop distributions. So main four distributions. One is Hadoop. You have HDFS. Oh, okay, then you have yarn. Then you have this hive or HBase. So the main are there. Then some commercial distributions are also there. It's just a diagram. You can just look into that. It's only half page in the textbook, so you don't have to worry much about that. Hadoop versus SQL. You have to see a scale. This is scale up. This is scale out. And then batch processing, real-time processing. You have to talk about hardware, high throughput, low throughput, low latency, high latency, low latency, like that. Integrated Hadoop systems or market vendors. So this Microsoft, Google, Amazon, they all come under this. Then cloud-based Hadoop solution, Amazon Web Service and Google Cloud Platform like Google BigTree and all. So that comes under this. So all this is just in 1 or 2 pages in the textbook along with diagrams, so you don't have to worry much about that. Main things were this, and now this completes the first module. I hope you like this first module explanation. Before the examination we will go live, and that live session will also be available for everyone. So just comment that whether if you need a live session or not, and if you have liked this explanation, kindly do like and subscribe, so it will be very good for me, since I'm working so hard just to explain and taking a lot of time. So we'll see you in the next video.